afternoon, dear students. How are you? Yes. Do you remember what did we learn in the last class? Yes, something related to your red blood cells. What is the other name for the red blood cells? Yes, go out. You have it called erythrocytes. So, the erythrocytes are very, very important. Okay, because they carry the oxygen to the cells and tissues, so you really ought to honor them for their job. So today we are going to learn about the effect, which is called as the chloride shift here. So what is chloride shift? Chloride. What is the difference between chlorine and chloride? Have you heard about chlorine anytime? Yes. We generally chlorinate our water. It will be very, very helpful because it tries to kill the microorganisms. So chlorine exists as gas. If you just remove one electron from that, it becomes chloride. So we are learning about the shift. Shift is nothing but change related to the chlorine. It is becoming chloride, and this has got something to do with your RBC. So that is red blood cells. What happens in general? In general, when you take the oxygen is having the capacity to combine with the hemoglobin, and what basically happens is, RBC is not having any nucleus. So absence of nucleus. When there is absence of nucleus, there is more scope for hemoglobin pigment to be there, and what happens is, if hydrogen ions are there, and these hydrogen ions, okay, why am I talking about hydrogen ions? We are talking about plasma. What is plasma? The liquid portion of the blood. So first of all, we need to learn what is there. When carbon dioxide is being released after respiration, combining with the water, it is forming an acid called as carbonic acid, H2CO3. This is further split into or gets dissociated into H plus and HCO3 minus. So, what is happening when HCO3 minus is there? That is bicarbonate. So, this H plus ions, right here is this H plus ions I am trying to link with. The H plus ions, when they try to enter your RBC, okay? So, at one particular point, what is happening? When the plasma, the liquid portion of the blood, there is change in the pH, that addition of hydrogen ions will try to fluctuate the pH, and what basically happens, the water which is being formed there will also tend to come in. H2O is also coming in. So what happens? At this particular juncture, you will see that the RBC is swelling up. That means it increases in its size compared to its normal size. So there is every possibility that it starts bursting. To cancel off that effect, you have the chloride ions which are there in the plasma, and these chloride ions tend to enter in. Why? In order to maintain the electrical balance, or to have the electric balance or electric balance, you have the tendency of chloride ions entering in. So what is happening? To have the charge, okay, the positive and negative charge being maintained in an equilibrium way, you will see that the chloride ions are moving into the RBC membrane in order to maintain the electric balance, and pH is being maintained. So this type of movement of chloride ions into the RBC is called as chloride shift. Okay, then this is okay. So the chloride shift is usually asked in the examination. So in order to explain the chloride shift, you need to start your answer number 1 with RBC, number 2. Okay? RBC is also called anthracite. Then we need to talk about the carbon dioxide gas which is being released out of breathing, combined with water, forming carbonic acid, dissociating into H plus and HCO3 minus. So there is a tendency of water molecules moving from the plasma, lipid portion into the blood cell. So there is swelling of RBC. In order to stop this, the chloride ions now tend to move in from the plasma into the RBC, and thereby the electric balance of your RBC is being maintained. So when this is being maintained, the shift is called that shifting of chloride ions from the plasma into the RBC is chloride shift. It's a very important subtopic which is being generally asked for the short questions in the semester examination. Yes, thank you.